So now we're going to start talking about the length of an arc versus the measure of an arc. So I'm going to talk about arc length, which is basically the distance, and this isn't the definition, but it's the distance from one point to the next along a circle. So distance between 2 points on a circle. Okay, and the length of your arc has a lot to do with the circumference of your circle. And the first thing I want to talk about is pi. So pi is defined as the ratio of the circumference to the diameter of a circle. So that's the definition of pi. Pi is equal to, well, if you take the circumference, if you measure around a circle and divide by the distance across the circle, you get the same number every single time, which is pi. So that also means that your circumference is equal to pi times diameter, or your circumference is equal to 2 pi r, because your radius is twice your diameter, which that's actually what it is. So your circumference is distance around a circle. And so if circumference is equal to pi times diameter, or circumference is equal to 2 pi r. Okay, so arc length technically is a portion of the circumference of a circle. Okay, so if I gave you a circle and I said the distance, the circumference of the circle was 100 meters, and I said, well, here's a diameter, what would the length of the arc from here to here be? Well, the length of that arc would be 50 meters, because it would be half of the circumference. Of the circle. So we're just going to do a problem really quickly. So it says find the circumference. So for circle A below, the distance from A to C is equal to 4 units. It says find the circumference of A. So the circumference is going to be equal to 2 times pi times 4. So my circumference is going to be 8 pi. That's in terms of pi. It says find the measure of arc CBD. Well, the measure of arc CBD is going to be, that means the angle. That means it's going to be in degrees. Okay, that's the measure of the arc. Okay, it's basically how much of the circle is taken, not the length. And so the measure of CBD is 180 degrees. Okay, and this is what it means in terms of pi. And so it says find the length of CBD. Well, I know 180 over 360 is equal to, because that's the length of my arc over 360, is equal to, or the measure of my arc over 360 is equal to the length of my arc over 8 pi. Part over whole equals part over whole. Another way to think about this is, well, 180 over 360 is 1/2 is equal to x over 8 pi. I know if I multiply each side by 8 pi, that x, my arc length, is going to be equal to 1/2 of 8 pi. So x, my arc length, is going to be equal to 4 pi. So the length of CBD is equal to 4 pi. So there are a few formulas to actually go through when we talk about arc length, okay? I like to think about it as a proportion, okay? I think, okay, part over whole equals part over whole. So the measure of the arc over 360 is equal to the length of the arc over the circumference. Part in degrees over whole in degrees equals part of the length over whole length. Okay, so that's the first one that we can think about. So you could do, it could be the measure of arc AB over 360 is equal to the length of AB over 2 pi r. Or you could do the measure of your arc over 360 is equal to the length of your arc over pi times diameter. All said and done though, so this is the proportion. Okay. What's also true is this formula right here. That's kind of reflected there. The measure of your arc over 360 times your circumference is equal to your arc length. The measure of your arc over 360 times 2 pi r could also be equal to your arc length. These are all the same formula, okay? I prefer the proportion because it helps you solve no matter what you're given. So it says find the length of the arc indicated. So I know that the measure of my arc is 135 over 360, so degrees over degrees, equals, I don't know the length of my arc, so I'm going to call this x, over my circumference, which is 2 times pi times 16. And when it doesn't tell you to round, you're going to write your answer in terms of pi. So I have 135 over 360 is equal to x over 32 pi. We cross multiply. Okay, I end up with 360x. Sorry about that. Equals 135 times 32 pi. 360x is equal to 4320 pi. I divide by 360. I divide by 360. X is equal to, now you just kind of ignore the pi, it's actually going to be 12 pi meters, and don't forget your units. Okay, and that's part of the reason why you can use the formula for this one, because you could also have done 135 over 360 times 2 pi 16 is equal to x. That would also have worked, but it doesn't work in every single instance. Next one, it says find the radius of a circle. There's an arc measure of 270 and arc length is 18. So 270 over 360, arc measure over whole circle, is equal to my arc length, and this should be an 18 pi, I'll fix that in post, 18 pi over, now I know my formula for circumference is 2 pi r, so that's what I don't know. Now what's interesting about this is that my pi's divide out, and I can do 2 goes into 18 9 times. These zeros divide out. You can keep simplifying if you want. You can simplify your fractions if you want. 27 over 360. 9 goes into 27 3 times. 9 goes into 36 4 times. So you could, if you didn't have a calculator, you could do 3 over 4 equals 9 over r. Cross multiply. 3r is equal to 9 times 4. 3r is equal to 36. R, your radius, is equal to 12. And just pay attention here. It is going to be 12 inches. Number 3, find the circumference of a circle if the length of an arc which contains 36 degrees is 2 centimeters. So this one is just trying to find the circumference. So I'm going to do 36 over 360. And I know that my arc length is 2 centimeters over, and we're trying to find the whole circumference. I don't write the formula, I just write that. Now 36 over 360 is actually 1 over 10 equals 2 over x. X is equal to 2 times 10. X is equal to 20. If you look at our units, 20 centimeters. And that makes sense because it's 1/10 of the circle. 36 over 360 is 1/10 of the circle. In a circle whose circumference is 18 meters, find the measure of a central angle whose arc length is 6 centimeters. So we're trying to find the measure of the angle out of 360 is equal to, the circumference is 18 centimeters and the arc length is 6 centimeters. And like I said before, you can simplify beforehand. 6 over 18, well, x over 360 is equal to 1 over 3. I cross multiply, I end up with 3x is equal to 360. X is equal to 120. And so my angle would have to be 120 degrees. And so I want you to think about that. So the whole circle is 18. 6 would be about 6 out of 18 would be about how much of the circle taken. It would be about 1/3 of the circle, so from here to here. So that makes sense that the angle would also be 1/3 of the circle. Okay, sectors are the same. This is why I like teaching it this way. Sectors are a lot like your arc length, except instead of a portion of the circumference, it's a portion of the area of the circle. Okay. The area of a central angle bound by the sides of an intercepted arc. Okay. And so we do the same thing. We're just taking a portion of the area. So if I said the area of a whole circle, if I told you the area was equal to 50 meters squared, and I said, well, find the area of this portion, you'd say, okay, it would be half of 50, which would be 25 meters squared. So that's just a side example. It's going to be just a part of the area. And so you can do what we did before. You can do, so you have a formula. It could be measure of the arc over 360 times, and in this case, pi r squared times the area is equal to the sector area. Okay, I prefer to do a proportion. So, so the proportion I like to do is the measure of your arc over 360 is equal to sector area over area of your circle. And that way it's the same thing over and over again, except you're replacing, instead of doing area, you're doing instead of circumference, you're doing areas, but it's the same formula. So just find the area of the sector below. So basically you're finding the area of this right here. So for this, I look at what I'm given. I know the measure of my arc is 30 over 360 is equal to, I'm trying to find my sector area, and I know the area of the circle is pi times 9 squared. These divide out. You can simplify 1 over 12. Now you don't have to simplify, you can just cross multiply. You'll just be dealing with bigger numbers, but I think that you'll be fine because you all have calculators. So I cross multiply. 12 times x is equal to 81 pi. I divide by 12. X is equal to 6.75, and that's not rounded, pi yards squared. Okay, and make sure that you put squared in there. Otherwise you'll get otherwise points will be deducted because area is measured in units squared, because you cover something in squares, and that's what it's asking about. Okay, now here is an example where the proportion is actually, that's why the proportion is kind of better to do. So in this case, it says find the radius of circle in which a sector whose central angle is 40 degrees has an area of 16 pi meters squared. So we're given the central angle, which is 40, and we know it's going to be over 360, so that's not one part of our proportion. The sector area is 16 pi, and it says find the radius of the circle, so we're going to use the whole formula, so I know pi r squared. So these simplify out, the pi's divide out to be 0. These zeros divide out, 4 goes into 4 once, 4 goes into 36 9 times. So you cross multiply, r squared is equal to 9 times 16. R squared is equal to 144. So your radius has to be 12 meters. In this case, it's not meters squared because it's asking for just the radius. Number 3, in a circle whose radius is 6, find the measure of a central angle of a sector whose area is 27 pi inches squared. So we're being given the radius, we're given the central angle, or we're trying to find the central angle, so that's going to be x over 360. We know our sector area is 27 pi. Oof. Sorry, I put that in the wrong spot. I know that our sector area is 27 pi inches squared. I know area is pi r squared, so it's pi times 6 squared. So we have x over 360 is equal to 27 pi over 36 pi. Now what you have to think about is this taking up a good portion of the circle? 27 over 36. So I mean, you can kind of venture a guess. It's going to be 270 degrees if you cross multiply and solve. But 27 over 36 is 3 over 4. And that's about how much of the circle is taken with a 27 pi. So it's going to be 4x equals 3 times 360. 4x equals 9720, or is equal to 1080. Divide by 4, and my measure my central angle is going to be 270 degrees. And don't forget your degree symbol. Don't forget your units, especially in this unit. In a circle whose circumference is 16 pi, find the measure of a central angle of an arc whose sector area is 2 pi centimeters. So we're trying to find the central angle. We know it's over 360. Find the measure. Okay, it says the sector area is 2 pi, and we still, it gives us our circumference, and we need the area. Why does it give us the circumference? Well, I know circumference is equal to 2 pi r. So if my circumference is 16 centimeters, then I have enough information to find my radius. And this is not, this question does not come out nice. Okay, so my radius in this case is 16 over 2 pi, which simplifies to be 8 over pi is my radius. And so now I can use that. It's going to be pi times 8 over pi squared. So this is going to be x over 360 is equal to 2 pi over pi times 64 over pi squared. Now one of these pi's divides out one of these pi's, and so that's just going to be 64 over pi. So I cross multiply. It's 64 over pi times x is equal to 2 pi times 360. 64 over pi times x is equal to 720 pi. Now the reason why this doesn't come out nice is because I didn't make this problem come out nice. So I have to multiply each side by pi over 64. X is going to be equal to 64 goes into 720, 11.25 times. And pi times pi is pi squared. So it's going to be 11.25 pi squared. So my answer is going to be 11.25 pi squared degrees. But this is actually one of those problems, sorry. This is one of those problems where you're going to put it in the calculator. So you're going to round to the nearest tenth. So if you round it to the nearest tenth, it is approximately 111.0 degrees. And that's the answer to that one. Okay, so last thing is your annulus, which is basically, if you had a circle within a circle, it's the region bounded by two concentric circles. Okay. And concentric circles are circles one inside the other. with the same center. Okay, so this would be concentric circles. They have to have the same center. Now basically for these, to find the annulus, what you do is you find the area of your whole circle, of the bigger circle, and then you subtract, and that didn't work as well as I wanted it to. So let's try this again. You can find the area of the whole circle, and then you subtract the inside, the small circle, and that will give you the area that is left. So basically it's area of big minus area of little. Okay, and make sure you use the radius. Okay, so it says find the area of the annulus below. Okay, so the area of the big circle is 5. So I know that the area of the big circle, this is going to be pi times 5 squared. So when I do pi times 5 squared, that's going to be 25 pi. So that's going to be the area of this whole thing. But I don't want the area of the whole thing. I want to get rid of the inside. So how do I get rid of the inside? Basically, we're going to subtract the area of the inside right here, and that will give me the area of just the outer bound. So it's going to be pi, so minus pi times 3 squared, which is 9 pi. And 25 pi minus 9 pi is 16 pi units squared. And if you're not given anything, it should be units squared. All right. This one's a little tricky because I know a lot of you want to do pi 3 squared minus pi 5 squared. That is definitely not the case. First of all, it's going to give you a negative answer. Okay. What you need is you need the area of the big circle. So remember that that's going to be this whole thing, which is, so the radius of the big circle is going to be 8 centimeters. So it's going to be pi times 8 squared minus pi times 5 squared. So it's going to be 64 pi minus 25 pi, which is going to be 39 pi centimeters squared.